Jai Gurudev student. Today we'll start reaction with metals. Now your alkyl halide when react with magnesium in dry ether, it forms alkyl magnesium halide. General formula RMgX. This RMgX is called Grignard reagent. Reagent name is Grignard. Grignard reagent. Where the electronegativity of R is 2.5, electronegativity of magnesium is 1.2. So it is more electronegative, it attracts the electron pair towards it, acquires a negative charge, it acquires a positive charge. Now, although this bond is covalent, but it is highly polar. Now, Grignard reagent is highly reactive because electronegative difference. Grignard reagent prepared in anhydrous condition and in inert atmosphere, as it reacts with oxygen, carbon dioxide, etc. And Grignard reagent is a source of carboanion. It is a source of carboanion. So next we will do other reactions. This is your Wurtz reaction. In Wurtz reaction, what happens? Your alkyl halide react with sodium metal with another alkyl halide and in dry ether. Always you use dry ether, otherwise this alkyl halide converted into alcohol. So there is a loss of 2 NaX, R plus 2 NaX. So we are getting using one R, 2R combined together. So if you want to get double number of carbon atom, you have to use Wurtz reaction. Next one is Wurtz-Fittig reaction. Wurtz-Fittig reaction, this is your alkyl halide, then sodium, then this is another aryl halide. So there is a loss of this one. So this is alkyl aryl compound is formed plus 2 NaX. Obviously there is use of dry ether. Then another reaction is called Fittig reaction. To remove this one, in presence of dry ether, obvious, you have to get the biphenyl is the product. This is for Fittig reaction. Then chemical properties of chlorobenzene. Properties of chlorobenzene. So if you have chlorobenzene like that, and chlorobenzene undergo nucleophilic substitution reaction with difficulty. In chlorobenzene, this is one bond, this is another bond, this is another bond. So why it is undergo nucleophilic substitution with difficulty means OH cannot replace the Cl. Why it is so? First of all, there is 2 electron, 2 electron, 2 electron. So first of all, due to repulsion by 6 pi electrons, the OH does not enter. Second point, this bond acquire a partial double bond character. Due to resonance, this one acquire a partial double bond character, and hence double bond is difficult to break. That is why OH cannot replace Cl. Third point, this carbon is sp2 hybridized. This carbon is sp2 hybridized, and sp2 hybridized carbon, actually although its bond is formed, it take back this one sp2 due to hybridized, this bond length become 169 picometer. The bond length becomes shorter and difficult to break down. In other cases, the bond length become longer, that is 177 picometer. So that is the reasons why the nucleophilic substitution does not occur. Although under some drastic condition, nucleophilic substitution may occur. So if you have chlorobenzene like that, and if you want to have this one, Cl must be replaced by OH. So this plus NaOH, and reagents you have to use 623 Kelvin, 300 atm pressure, and H positive. That gives you OH there. So OH can replace Cl, but under high conditions. Temperature is high, pressure is 300 atm, this is very high. Now condition can be if you use some electron withdrawing group at this position, then we can use some milder condition. In that case, temperature is 468 Kelvin, rest conditions are same. So if I using the electron withdrawing group, conditions in favor of nucleophilic substitution reaction. So sometime if you use 3 such groups, here is a NO2 group, here NO2 group, here NO2 group. So we are using electron withdrawing group 3 times. Then if you do only warm, you gives you the product. Next, next we are drawing the resonating structure of chlorobenzene. This lone pair become bond pair, this bond pair become lone pair. So we are getting this resonating structure with negative charge here. This lone pair become bond pair, this bond pair become lone pair. This lone pair become bond pair, this bond pair become lone pair. So we are getting this chlorobenzene is ortho para directing. Now if ortho para directing towards electrophile, actually if positive charge come, it will enter at ortho or para position. Now if I draw the chlorobenzene, if this one reacts with Cl2 in anhydrous AlCl3, So Cl2, from Cl2 there will Cl will come, Cl positive will come, and it enter at ortho position or it enter at para position, ortho para product. Out of that ortho product, due to more repulsion, there is less repulsion, so para product is the major product. If you do reaction with concentrated HNO3 and concentrated H2SO4, from that we are getting NO2 positive. So NO2 positive enters at ortho or para position. If we use H2SO4, so H2SO4, from that SO3H is the positive part, it will enter in the ortho or para position. Now if I add CH3Cl, CH3 positive part, it will add at ortho or para position. Now if I use CH3COCl, so it enters into ortho or para position. So this one is called Friedel-Crafts alkylation, and this one is Friedel-Crafts acylation. So this concludes the unit 1 in the organic chemistry. Next class will start unit 2.